everyone, welcome to my YouTube channel. I am Sushmit and today I will detaily make you understand about the PWM concept used in Arduino, and I will demonstrate it with the help of a LED light, a DC BO motor, and the most interesting part, I will also demonstrate it with the help of an oscilloscope so that you all can visualize it and understand it properly. So without wasting any more time, let's dive into it. Before entering into PWM, I would like to ask you a simple question. Suppose I say you to change the speed of this motor with the help of a battery. Now the first thing that will come to your mind is that you will add a rheostat to the battery, vary the resistance with the help of that, and thereby control the speed of this motor. But in that case, if you notice carefully, there is a great loss in the resistance that you are using. Now the second problem is that you cannot control the speed of this motor using Arduino or any other electronic circuit with the help of the rheostat concept. In digital electronics, we basically use high and low concept, where high indicates plus V voltage and low indicates 0 voltage. Neither can you control the brightness of these simple LEDs using the rheostat concept by the Arduino. Now to solve this problem, we introduce PWM concept in digital electronics. In the previous video, I have clearly shown you the PWM pins in Arduino. Now friends, let us understand what PWM is. Now as I told you, the main significance of PWM is controlling analog devices using the digital signal. That's the main point. So we can see here clearly, PWM is a very clever way to use electricity to control analog devices via digital signal. Now here is the main concept of what PWM is. Note it very carefully. Now in PWM, what does P signify? It is pulse. So here we see these are the pulse. With the help of these pulses, we control the voltage so that we can regulate our devices just like the LED bulb and DC motor. We can control the brightness of the LED bulb, we can change the speed of the motor, and we can implement it in many other ways. Here we see a low average voltage in these pulses, whereas in this pulse we see a higher average voltage. Now just as in rheostat we vary the resistance, here we vary the voltage with the help of these pulses. The magnitude of this voltage depends on the width of these pulses. You can see the width is very narrow here, and here we can see a broader width. So in this case we receive a higher voltage than in this case. Now to measure the width of these pulses and thereby measuring the average voltage, we introduce a new variable. Here you can see the term we have introduced to measure the width of the pulses is known as duty cycle. Now what is this duty cycle? The duty cycle is the ratio of pulse width to the period. Now note carefully that this part is the period of this wave, this one crest and one trough. So in case of this wave, this length is the time period and this TW is the pulse width. Now according to the definition, we see that the duty cycle is equals to TW divided by capital T. The more the pulse width will be, the more will be the duty cycle, and thereby the more will be the voltage that the LED bulb will receive. So by seeing this parameter, we can guess about the voltage that is supplied to our appliances. Now let us note another concept in this graph. These are the two levels. This level is the high level and this level is the low level. Follow my cursor carefully. The difference between these two levels is the voltage we supply. Now as we know, in digital electronics we just have two, either high or low. So here this is the high and this is the low. Now you might be thinking, if I just on and off the bulb, then how will I change the voltage? The LED will just glow and dim off. Now to clear this concept, I will directly take you to the Arduino website. Now note another point, that we implement PWM in Arduino with the help of analog write function. Now I will make detailed videos about these functions very soon. Now let us come here. You can see this is the board, this is the PWM pins and the PWM frequency. This is the thing I am talking about. In Arduino Uno, you can see these pins support the PWM facility. Now I guess I have shown you these pins in my previous video. So if you have not seen, take out your Arduino and detailly notice it, and you will notice few wave-like structures in front of these pins. Now let us come to the frequency. Note here carefully that we have a frequency of 490 Hz for all these pins except 5 and 6, which has a 980 Hz of frequency. Now just think, in 1 second of time those pulses will go up and down for 490 times. Now can you imagine a light to go on and off for 490 times per second? So by using this concept of frequency, we get an average voltage and thereby the brightness of the LED becomes low. Now if we vary these width of the pulses, we will get the average voltage according to that. I guess now the concept is pretty clear to you. Now if you want to calculate the duty cycle in percentage, so here we will just multiply it with 100 and put a percentage here. Now let us quickly see how to connect all the components to Arduino to demonstrate this phenomenon. So let us go to the circuit designing part. Now this is the diagram I have just made. It consists of the Arduino Uno board, a red LED and a potentiometer, which gives the signal to control the brightness of this LED. I have connected the positive terminal of the LED to the PWM pin 9 and the negative pin to the ground. In case of the potentiometer, I have connected the center signal pin to analog input A0 and the negative pin to the ground and the VCC pin to positive 5 volts. Now this completes our simple circuit. Now let us practically demonstrate it to understand the PWM concept. Now let us quickly see the basic components. This is the 10K potentiometer. This is the red LED. I have additionally used a 220 ohm resistor to limit the current, but any value between 150 to 350 ohms is suitable. Now let us parallelly see the Arduino code. Trust me, it is very simple. Now this is the simple code that we need to control the light by PWM. In these two lines, we initialize the pins that we are currently using. The A0 pin is used to take the input and pin 9 is used for output. Now inside the setup block, we set up these two pins as input and output respectively. Now we enter into the logical part of the code. Now note these lines very carefully. I have commented. Here we are taking the potentiometer as the input signal. We give our signal to the Arduino through this potentiometer. Now a quick fact, the input channel of Arduino is of 10 bits. Remember it carefully. Now you can calculate 2 raised to the power 10 is 1024, and as it is of 10 bits, so the values of the input channel of Arduino can vary from 0 to 1023. You can see it here. And the output channel of Arduino is of 8 bits, so it can accept values from 0 to 255. Now in this line, we store the value that is inputted from the potentiometer into a variable named data. Currently, this data will have a value in between 0 to 1023. Now we need to convert this into the range of 0 to 255. For this reason, we use the map operation, which maps our data from this range to this range, which perfectly serves our purpose. And now finally we arrive to the line which implements the PWM concept. In this line, you can see a function known as analog write. This function takes two values. Firstly, it is the pin number, and secondly, it is the PWM value. Now after mapping, we have got our PWM value into our variable data using the operation of map, and then we give a 10 seconds of delay. So now I will upload the code into the Arduino. Now finally we have uploaded our code to the Arduino. So we will vary our potentiometer to change the PWM signal and thereby change the brightness of our red LED. So let's do it. I am rotating it clockwise. You can see the brightness is gradually increasing, and now it has reached its maximum potential. Now if I rotate it anti-clockwise, it will gradually decrease its brightness by the PWM concept. You can see it is decreasing, and finally it is off. So we have practically demonstrated the PWM experiment. Great job! Now, as I said you in the beginning, I will help you to visualize the PWM concept using an oscilloscope. So let's start the simulation. Now finally, I have set up all the components. You can see I added a 220 ohm resistance here and the main component, the oscilloscope. I have set the time per division to be 1000 microseconds. Now let us start the simulation. You can see now if I rotate this potentiometer, this LED will have varying brightness. Now see, I am rotating it, and the LED gradually increases its brightness, and now it is at maximum brightness. Now let us notice the change in the oscilloscope, which is the main thing. Now see, as I rotate it little bit, you can clearly see here the pulses. This structure is particularly called as the pulse width modulation. These are the pulses you can see clearly. As I have rotated it to a small extent, so the width of these pulses is very small, and thus the average voltage is also very low, and so our LED is also very dim. Now I will gradually increase it, and you can see the width of our pulses is increasing gradually, and our LED is also glowing better. Now this is the 50% stage. Here our duty cycle is 50%. You can see for 50% of the time period it is on, and for the rest of the time it is off. Now I will increase it further, and you can see it is further increasing. Now at this time you can see the pulse width is almost equal to the time period, and now the duty cycle is almost equal to 100%, and our LED is also at its maximum brightness. So this is all about the simulation in the oscilloscope. So friends, finally we have learned the fundamental concepts of PWM and also demonstrated it with the help of the LED. Now you might be thinking that I only controlled 5-volt appliances using the PWM. But now I will control a 12-volt DC motor and a LED strip using the PWM concept. I have shown it in the next video, so click that and watch it.